All right, so the instruction set here is to do your best to do it by hand, very least one side up for using Desmos. I think there's some special patterns in here that are pretty rough, so I didn't actually create these problems. These came from the Envision Algebra 2 book. But like I'm going to try and do the first one, all right? So I'm going to one side everything, and I'm actually going to shift everything to the right because that's going to make this guy positive. So I'll have a 0 on the left. I'll have 3x cubed. I'll have a negative x squared, which becomes positive, plus 2, so plus 2x squared. 6 minus 54, I feel like that's negative 48x. And then 20 plus 40 is 60, so plus 60. Will that factor? I think I can work with this. I can pull an x squared, and I'll have 3x plus 2. Maybe I can't. Yep, hold on. I'm an idiot. I'm an idiot. I do have a 3x cubed. I also have a 3x squared, don't I? And then 6 minus 54 is still negative 48. That kind of stinks. And then I have the plus 60. This is not a factoring by grouping because you could pull this and you'd have x plus 1. But I don't know how to make that x plus 1. So it's not a factoring by grouping. It certainly does look like something that would factor. But anyways, you're supposed to find all solutions. So it's not just like you're going to look at Desmos and be done with it, because you're not. So what we had a 3x to the third plus a 3x to the second minus 48x plus 60. All right, so here's my one real answer. Oh, there happens to be another real answer. Okay, what's cool about this is how many times these answerings are happening. This is happening. Oh, I see how it factored now. Ugh, bummer. This is a touch. It's happening twice. I'll go ahead and steal this real quick so I can use it for instructional purposes. This is a touch. Happens twice or more. And this is a crossing, which happens once or more, or 3 or 5 or so forth. Now we had x cubed. So x equals negative 5 happens once, and x equals 2, this has a multiplicity of 1, has a multiplicity of 2, because 2 plus 1 is 3. So x equals negative 5 with a multiplicity of 1, x equals 2 with a multiplicity of 2. I was hoping some of these would factor, but that one did not. I pulled that straight out of a textbook. Apparently nothing special about it. I'll do 10. What are the real and complex zeros of this polynomial as shown in the graph? Use these zeros to completely factor this thing over the complex number system. So let's see what happens if we pull out these zeros. We may have to check for multiplicity. What we have here is we have a whole bunch of touches, we have a whole bunch of crosses. So your crosses have odd multiplicity. That means they happen at least once, but they may happen 1, 3, 5, etc. times. But they will happen an odd number of times over and over and over. And the question is, how many times do they actually happen? That's the real question. And also the question is, are there imaginary answers to this thing? That's the other big question. So let's see what we got. We got a couple of zeros here. Our zeros are x equals 1. We're going to factor, by the way, -1, x equals 0, and x equals 1. So our known factors, change sign, kids, are x plus 1, x, because this is x minus 0, and I said I'd judge you, x, and then x minus 1. I have to get to a 7th degree polynomial, and I only see maybe a cube. That's all I see. So let's pull some stuff out. I'm going to do the 0 first because it's small. Coefficients are 1, 0 because there's no x to the 6th, 2, 0 because there's no 4th, -1, 0 because there's no square, -2, and 0 because there's no constant on the end, and that 0 needs to be there. That's part of it. Hopefully that's 8 things. It looks like 8 things. So we're going to drop, and we're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. Sorry. That's not -1. That's not 0. That's -1. I got 0 happy. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. And we're going to multiply, and we're going to add. And of course, I got a 0. All right. Thought I changed colors there. Everybody sees me clicking that, right? Bring it over just to that -2. Now let's do 1. That's supposed to be a 1. We're going to drop. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We're going to multiply, and we're going to add. We got a 0. So let's do this again. This time we're going to use the -1. We're going to drop. We're going to multiply, and we add. We 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 multiply, and we add. So let's see what we're left with here, because this might factor. It kind of looks like it will. We have a remainder, a constant, an x squared, an x cubed, and an x to the 4th. We have x to the 4th plus 3x squared plus 2, and we're going to factor it. It takes an x squared and an x squared to create x to the 4th. Factors of 2 are 2 and 1. Now, I want the complete factorization of this thing. The complete factorization over the complex number system. So I'm going to set this thing equal to 0 so that I can find my zeros. All right, so if I have x squared plus 2 equals 0, I'm going to shift my 2 over. X squared is -2. I know this is real. I also know I need 2 answers. Sorry, I know it's not real. It's the plus or minus the imaginary root of 2. So think about this. If x is the positive imaginary root of 2, then the factor is x minus the imaginary root of 2. And if x is the negative imaginary root of 2, then I am x plus the imaginary root of 2. So I have 2 more factors. Do the same thing on this one. It's not necessarily hard. It's long, I guess. So x squared equals -1. X is the root of -1. That's a definition. I is defined to be the root of -1. So x is plus or minus I. So I've got 2 more factors here. If x is positive I, the factor is negative I. If x is negative I, the factor is positive I. And again, don't mute me. Don't mute me. There's instruction going on. You're watching this video because you don't know what to do. Don't mute. Don't blindly copy. By the way, you'll notice 7th degree polynomial. 1, 2, 3, 4, 5, 6, 7 factors. All right, find the zeros of the function, describe the behavior of the graph at each zero, i.e. is it a crossing or touch? You do this by factoring. That's factoring by grouping, that's pulling x. They're all about the same level of difficulty. They really are. I'm just going to do this one here. I'm going to guess, based on me being the problem creator here, that I used a 9x squared and an x squared. Actually, I didn't make this one. This is Envision algebra stuff. Factors of 16 are 4 and 4. 4 times 9 is 36. 4 times 1 is 4. I can get there. Make them both negative. Now, I'm not done factoring. I'm not. There's an a squared minus b squared pattern out there, which factors as a minus b times a plus b, or vice versa. And when I look at 9x squared, I see a 3x that's squared. When I look at 4, I see a 2 that's squared. So there's more factoring to do on her. She's 3x minus 2 times 3x plus 2. And the same pattern applies here. So that factors as x minus 2 times x plus 2. And it says describe the behavior of the graph at each zero. So I'm just going to do a rough graph. This is an x to the even. Of course, we do this by, actually, I don't know that you need to do this. Never mind. I can look at multiplicity. All right, the understood exponents on each of these factors are 1. So by multiplicity, at each zero, the graph crosses the x-axis because 1 is odd. Odd multiplicity crosses. All right, while I'm at it, may as well do 6 for you, because God love you in factoring. All right, so I know I see 3 terms. It's definitely not factoring by grouping. I can pull an x from everything. That's x squared minus 8x plus 16. And this is kind of what, this one's lame too. It is. It's going to be this kind of the same. To make an x squared, it takes an x and an x. Factors of 16 are 4 and 4. To add to a negative 8, they're both negative. Okay, so this one's kind of nice. This is x times x minus 4 squared because it happened twice. So it's not too bad. Your zeros are x equals 0, and it has a multiplicity of 1, and x equals 4, which has a multiplicity of 2. Remember, odd multiplicity is a cross. This is a crossing. We cross the x-axis. And even multiplicity is we touch the x-axis. And I should have probably listed the zeros over here. Your zeros were x equals 2/3, x equals negative 2/3, x equals 2, and x equals negative 2. And they all had a multiplicity, or they happened 1 time. All right, so I'll do one of these. You're supposed to sketch the graph by finding the zeros, the y-intercept, the x-intercept, and the end behavior, which means you think the power function. Power function on this guy is 3x cubed. That's an x to the odd. So whenever I actually do some graphing, I'm going to start low and I'm going to end high. You have a quiz Friday, I think. That's part of it. Your zeros you can find by factoring. 0 equals x times 3x minus 9x minus 12. I probably should have pulled 3 out of that. Let me go back and do that. 0 equals 3x times x squared minus 3x minus 4. That'll factor some more. Factors of 4 are 1 and 4. I know that negative 4 plus 1 is negative 3, so there's my complete factorization. So if I use a zero product property, I have x equals 0, which is the order pair 0, 0. This is x equals 4. Remember y was 0. This is y at 0. So I have 4, 0. This is x equals -1. So I have -1, 0. Those are my 3 x-intercepts. And remember, I also know how it starts and ends its day. But I have 0, 0, 1, 2, 3, 4, 4, 0, and then -1, 0. To find a y-intercept, we let x equal 0. That's what you do. So the y-intercept is going to be equal to 3 times a 0 cubed minus 9 times a 0 squared minus 12 times a 0. And by golly, that's 0. Which of course it is, because you already plotted it right there. I don't know why I did that there, but I found the zeros, which are the x-intercepts. Don't know why I asked for it twice. Maybe I was trying to get y'all to think. I don't know. But here's your rough graph. We start low. Think about your multiplicity. Every one of these zeros had odd multiplicity. Okay, they all had odd multiplicity. So they all cross the x-axis. We're going to have to cross that 0, which means we're going to have to turn and come back down. And I don't know when or where it's going to happen, but we're going to have to go back up and pass through. Both of these are odd multiplicities. You know what? I'm going to change this one. I'm going to make that a square. It means you're going to have to touch there. So let me change that. Because at least one of those needs to be a touching situation. To the second. All right. Back to the previously scheduled programming here. All right. Now this talks about doing it by hand, where these graphs cross paths and so forth. And it says do it by hand, so evidently it works out. Two things intersect when they are crossing paths or when they are equal to each other. We're going to move that 12 back over because by and large we want to be set equal to 0 in Algebra 2. That's what Algebra 2 does. It sets everything equal to 0. And 20 plus 12 is 32. And I'm going to let you take it over from here. This will factor by grouping. And you are going to finish this. I'm not going to finish it. But focus on these two, figure out what's common, and then focus on these two, and that's a really bad looking 32, by the way. It's supposed to be a 32. And you can factor it. All right. How could you use technology? Well, I'm done. These questions are for y'all. So there is the remainder of your homework for 3.5, and it's a long assignment. I know it is. It takes practice to get as good at me. So keep practicing.